Okay. In the class 11 12 chemistry, in many chapter we need to find out the oxidation number of the elements. So the rules to find out the oxidation number is given in the redox reaction chapter, class 11 chemistry redox reactions. Okay, I will go through the rules here. These are the 6 rules. Rule number 1: in the elements in the free or uncombined state, each atom bears an oxidation number of 0. Evidently, each atom in H2, okay, has the oxidation number of 0. This is the rule 1. Okay, so this is the atom without any charge, aluminum 0. Okay, H2, each atom hydrogen is 0, Cl2 Cl is 0. Okay, this is the rule number 1. Okay, rule number 2: in for an ionic compound, okay, for ion composed of only one atom, the oxidation number is equal to the charge on the ion. Thus for Na plus means only positive charge, so the oxidation number is +1. Okay, okay, Mg2 plus 2. Okay, this is for the single ion. Okay, for alkali metals have the oxidation number of +1. All alkaline earth metals have the oxidation of +2. Aluminum is regarded to have the oxidation number of +3. Okay, so oxidation number of Na plus is +1, Mg2 plus is +2, Cl minus is -1, O2 minus is -2. This is a charge for alkali metals, that is in the group 1 in the periodic table. So these are the alkali metals. These are all alkaline earth metals. Okay, these are alkali metals, these are alkaline earth metals. Okay, alkali metals. So example, in KCl, K is +1. Okay, this is alkali metal, alkaline earth metals. Okay, in the MgCl2, the Mg is +2. Okay, aluminum +3, Al2O3 +3. Okay, so that is rule number 2. Okay, rule number 3: the oxidation number of oxygen is more in most compound is -2, -2. However, we come across two kinds of exceptions here. One arises in case of peroxide and superoxide, the compounds of oxygen in which oxygen atoms are directly linked to each other. While in peroxide, okay, this each oxygen atom is assigned the oxidation number of -1. In superoxide, each oxidation number is assigned to -half. Okay, the second exception occurs when oxygen is bonded to fluorine. In such a compound, the oxygen difluoride and the dioxygen difluoride, the oxygen is assigned a positive oxidation number. Okay, for the oxygen. Rule number: the oxygen is normally -2. Example in these compounds. Okay, the aluminum 2 Al plus 3O equal to 0. That is, this is a neutral compound, so that is why the overall charge is 0. So aluminum 3, oxygen is -2, 6 minus 6 is 0. With fluorine fluorine has the negative one. Okay, so this is the exception. Okay, normally it has negative 2 oxygen, but with fluorine overtakes. Fluorine has negative 2, negative 1. So in this compound OF2O plus 2F equal to 0, F is negative 1. Okay, then the oxygen is plus 2 here. So normally it is negative 2, but in this compound it is a positive 2, positive. So with fluorine it is only the oxidation number of oxygen is positive, because fluorine is negative, so it has to be positive. So here in this compound O2F2, here fluorine is this oxygen is positive 1, here positive 2, here positive 1. So the two different oxidation state with fluorine here is okay. With peroxide Na2F2, so here oxygen is negative 1. So here see, with peroxide it is negative, with fluorine is a positive. Okay, with superoxides, example this KO2. Okay, K, you know, this group 1 element, this alkali metals, so is a positive one. So here the oxygen is negative of. Okay, this is the rules for the oxygen. Now for rule number 4. The oxidation number of hydrogen is positive 1, except when it is bonded with the metals in the binary compound, that is compounds containing the two elements. For example, okay, so it is positive 1 with the non-metals and negative 1 with the metals. That is oxidation number of hydrogen. Okay, hydrogen is positive 1 with non-metal and negative 1 with metal. So this is a non-metal in NH3. So we are going to use positive 1 for the hydrogen in the non-metal. So we are finding the N equal to negative 3. Okay, but with metal it is a negative 1. Okay, here. So we are using negative 1. So here hydrogen is negative 1. Okay, the NaH. Rule number 5, in all compounds fluorine, okay, fluorine is a negative 1. Other halogens, chlorine, bromine, iodine also have the negative 1, but with the exception in the with the oxygen, they occur with the halogens. The chlorine, bromine, iodine when combined with oxygen, for example in oxoacids and oxoanions, have positive oxidation numbers. Okay, the chlorine, bromine, iodine when combined with oxygen, they have the positive oxidation number. That is rule number 5. Okay, this is the rule number 5. Fluorine always 1, but the chlorine, bromine, iodine with oxygen they have positive. Okay, see here in this with oxygen ClO2 O negative 2. Okay, so if you send Cl is positive, Cl is plus 4, so this is positive with oxygen, but negative with the other compounds. Okay, see here KCl, so here chlorine is negative, that is negative 1. Okay, so it is positive with oxygen but negative with other compounds, but fluorine always negative 1 with all the compounds. Okay, the algebraic sum of the oxidation number of all atoms in a compound must be 0. In a polyatomic ion, the algebraic sum of all oxidation number of the atoms is equal to the charge on the sum of the oxidation. Okay. So in this compound carbonate ion, this is the this total oxidation number is equal to the negative 2. So here if you take this neutral compound KCl equal to 0, that is K1 Cl minus 1, 1 plus negative 1 is 0. Okay, so this is the sum of the oxidation numbers. So the neutral compound equal to 0, but for a ionic compound, that is equal to the charge. For example, the carbonate ion, okay, CO CO3 2 minus C plus 3Y equal to negative 2. This is the net charge. Okay. So now the PO4 3 minus P plus 4, okay, equal to negative 3. Here this is the net charge. Okay, these are the rules. Now issuing the rules, we will see the how to find the oxidation number in the compounds. Okay, so if you take this compound Fe3O4, there is no rule for the Fe, so we have to find out the oxidation number of the Fe using the rules of the oxygen. Okay, oxygen is normally negative 2, so 3Fe plus 4O equal to 0. This 0 based on the rule number 6, that is algebraic sum of the all oxidation numbers should be 0, that is based on the rule number 6. So now we are going to use the rule. We know oxygen is normally negative 2, so substituting we will get the Fe is plus 8 by 3. Okay, this rule number is 3 is for the oxygen, normally 2, my negative 2. Okay, so for this compound we have found out the oxidation number Fe and O. So because Fe no rule that we found. So in this you see SO4 minus 2, the net charge is negative 2, S plus 4O. So here for sulfur there is no rule, so we are going to find out oxidation number of the sulfur using the rule of the oxygen. Okay, negative 2. This is again based on the rule number 6. Sum of the oxidation numbers is equal to the net charge, that is the negative 2 for the ionic polyatomic ion. Here H2S 2H, we are going to use the hydrogen rule here. Okay, so hydrogen is 1 for the non-metals, it is negative 1 for the metals. So we are going to use the hydrogen rule here to find out the sulfur. So sulfur is negative 2. So now we will see this compound. In this copper CuCl2 Cu2Cl2. See here, copper we don't know the rule, so but we know for the chlorine. Chlorine normally negative 1. So using that rule we found copper is plus 2 oxidation. This is C rule number 6. Rule number 5 for the halogens. Okay, Cl. Normally negative 1, but with oxygen it differs, but here negative 1. Okay, so here this is positive 1 for the copper existing 2 oxidation state. You see CuCl2 Cu2Cl2, here C plus 1, here plus 2. These are the rules we are using. 5 is halogen rule, 6 is the algebraic sum. Similarly, we have for the manganese MnF4, we are going to use for the rule of fluorine, negative 1. Okay, fluorine is always negative 1, so based on that Mn is plus 4. Here Mn2O7, we are going to use rule of the oxygen. Okay, then using Mn is plus 7. Okay, so like that you can use the various rule, find out the oxidation number of the elements.